Welcome to Sequences and Series. So in this video we're going to look at two different types of things, a sequence and a series. A sequence is a list of numbers that follows some rule, like this sequence, 1, 4, 9, 16, 25. Those are squares, obviously, like 1 squared, 2 squared, 3 squared, 4 squared, and 5 squared. A series is the sum of a sequence. So the numbers are the same, but now we're adding them together. A sequence is just a list, a series we're adding them. The tricky part comes as we try to write the sequence in a more general form, or we're trying to write it as like a formula. So we have this is just a general way to write a sequence, any particular sequence, it doesn't matter. Just in general, a sequence is a sub 1, a sub 2, a sub 3, and then dot 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 until you go up to the highest term, a sub n. These are supposed to be curly brackets, but I'm terrible at drawing those. So as a formula, the way that we can write this is a sub I, and then I goes from 1 to n. So this is kind of like what we do with integrals, where we have a lower bound and an upper bound. So we start at the bottom one and we go up to the top one. And we're just replacing this I in here with whatever numbers we do. So we have a1, and then we still have to go from 1 to n, so then we put in 2, and then 3, and then so on until we get to n. A sub I is what we call the general term, so this thing right here is the general term. And for an example down here, so say we have the sequence 1/2, 2/3, 3/4, 4/5. We can write the general term as n on the top, because I count n equals 1, n equals 2, n equals 3, and n equals 4. And then on the bottom, this is still my first term, so n is still 1 here. But I need to figure out if n is 1, then how do I get 2 on the bottom? So I just add 1, because n plus 1 is 2, or 1 plus 1 is 2. 2 plus 1 is 3, so our second term, n equals 2. The bottom is 3. So n plus 1 tells us the denominator. And then n starts at 1, because that's what we decided. It was n is 1, and then when we plug in 1, we get 1/2 to this formula. And then we go all the way up to n is 4, because when we plug in 4, we get 4 over 5. And our general term, a sub n, is n over n plus 1. So each one of these can be described by that general formula depending on what n is. Now here's the tricky page. Try to come up with the formulas for these two sequences. So here's a general thing. Basically figure out what the pattern is and then write it as a general term based on n, which is the number of the term. And then for the last two, you might want to start with these. Write out the sequence based on the formula that they give you. So like for this one, we're going from n equals 1 to 4, so you need to plug in 1, and then the next one you plug in 2, and then 3, and then 4, and that's your whole sequence. Same thing down here. Alright, so pause the video, try those, and then we'll talk about them on the next slide. Alright, so for example, or for problem number 1, I noticed that I'm adding 3 each time, and I started at 5, so this is a lot like writing a linear equation, because if I graphed that, it would just give me a line with a slope of 3. So because I know I'm going up 3 every time, I have a 3 times n, and I didn't start at 3, I started at 5, so that means I need to get to 5 somehow, so I start with a little plus 2. So n is going from 1 to 5, and the general term is 3n plus 2. The next one is a lot trickier. I know I have an alternating sign, because I go negative, positive, negative, positive, negative, which means I need this right here, -1 to the n, because when n is odd, I get a -1, and when n is when n is even, I get a positive number, like -1 squared is a positive 1, which gives me a positive number. The next thing I notice is that I've got 3's, because there's something with a 3 here, there's a 3 there, a 9, a 27. Those are all multiples of 3, or powers of 3, sorry. So the first one is like 3 to the first power, and then I don't have a 3 here, so maybe I can think about that as 3 to the 0th power. This 3 is in the denominator, so that's 3 to the -1, and I wrote those over here. So we have 3 to the first, we have a missing 3, 3 to the -1, 3 to the -2, and 3 to the -3. So 3 is counting down, which means I have a negative n, because it counts down by 1 every time, and I started at a positive 1. So to get to that positive 1, I have to add 2 right here. And then 2, I also noticed that I have 2's in here, because I have a 2, 4, 8, 16, and I'm missing a 2 here. So basically I have 2 to the 0, 2 to the first, 2 squared, 2 to the third, 2 to the fourth. So I'm just doing 2 to the n power, whatever my, oh, that should be n minus 1, not just n. Let's fix that really quickly before we forget. So that should be n minus, oh, squeeze that 1 in there, n minus 1. Alright, for the next problem, we have this term. So basically we're just going from 1 to 4. So I plug in 1, I plug in 2, I plug in 3, and I plug in 4, and then I simplify each of those, which gives me this sequence right here. And then for the last one, same thing. I already have the general term, so I'm just going from 1 to 4. So I just plug in 1, plug in 2, plug in 3, plug in 4, and then simplify to get that sequence. Alright, so similar to sequences, we can also write a series as a formula. A general series looks a lot like a general sequence. We have a sub 1 plus a sub 2 plus a sub 3 dot 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 all the way up to a sub n, which is our highest term. As a formula, though, it looks a little bit different than a sequence. So a sequence we write with the curly brackets. A series uses this symbol right here, which is a capital sigma. That's how you spell sigma. And it's known as the summation sign, or you can say it as the sum of, depending on what you have written after it. But basically, I'm just going to call it a summation, or I'll call it sigma. So sigma tells us that we're adding things together, and then we have a lower bound and an upper bound, so we're going from 1 up until n, and you can see that in our sequence. We started at a sub 1, and we ended at a sub n. And then my general term, just like I have a general term for a series, a general term for a sequence, I also have a general term for a series right there. So my example down here, taking the same series that we looked at the beginning, it's just the sum of all of the squares up until 5 squared. So we can write that as 1 squared, 2 squared, 3 squared, 4 squared, and 5 squared, which gives me a general term of n squared, and n is going from 1 to 5, and then sigma shows that it's a series that I'm adding these terms. So here we go again. We're going to try writing the series as a formula, or vice versa. If I give you the formula, then write out the series that goes with that formula. And so pause the video here. When you're ready, we will talk about these. Alright, so here we go. The first one is, they already gave us the formula, so we're just going from 1 to 4. So we take this general term and we plug in 1 right here, and then we plug in 2, we plug in 3, we plug in 4, and then we see what we get, and we simplify, and this is all we have to do. You're not, at this moment, you are not looking for an actual sum. We just want to have, we want it to look like a sequence where we just have the first 4 terms listed out. Alright, same thing with the next one. We're going from 1 to 3, with this being our general term. So we plug in 1, we plug in 2, we plug in 3, and then we simplify to get that. For number 3 and 4, you have to write the formulas. So for here, I noticed that I've got powers of 2 on the bottom, so I can think about these being powers of 2. 2 to the first, 2 squared, 2 cubed, and this one, really it's 1 over 1, or you can think about that 1 as being 2 to the 0 so that that pattern continues, because if I go the other way, I've got 2 cubed, 2 squared, 2 to the first, so 2 to the 0 should go right there. So my general term is going to be 1 over 2 to the n minus 1, because we're starting at 0 for our sequence. So n equals 1 going up to the 4th term, and our general term is 1 over 2n to the minus 1. You could also write this as n equals 0, and then you don't need that minus 1 here. It would just be 1 over 2 to the n, and you'd go from 0 to 4. 0 to 3. So that's okay too. Alright, and for number 4, I see that I have an alternating sign, negative, positive, negative, positive, negative. So my alternating sign gives me negative 1 to the n, and then my actual series is pretty easy because it's 1, 2, 3, 4, 5. So it's just whatever n is, that's the number that goes here. We're not doing anything to it. Now n goes from 1 to 5. I need a sigma. There's my thing to make my alternating signs, and then times n. It's hard to write the general form for a sequence and for a series, and they can get really complex, and it's okay if you struggle with them, because that's one of the hardest things to do with these. So here are some general tips about how to maybe write the general term. These don't always work. Sometimes you don't want to use these tips, but just, to get you started. So first thing, if the signs alternate, use -1 to the n or -1 to the n plus 1, depending on whether you need the first term to be negative or the second term to be negative. Even numbers can be represented by 2 times n. Odd numbers can be represented by 2n minus 1 or 2n plus 1. So like if I go 1, 3, 5, 7, then I will want to use 2n minus 1 because I'm counting by odd numbers. If I'm counting 2, 4, 6, 8, then I'll just use 2n because those are even numbers. If you have a fraction, then it might be easier to think about the numerator and denominator as being separate things. So figure out this, like, how can I represent the numerator with a formula, and then separately, how do I represent the denominator with a formula, instead of trying to think of the fraction as a whole thing, because that might be too much to take into account at once. And then, just for the last bullet point, just try things. Come up with a simple formula that maybe gives you something close, or it might be right for a couple of terms, and then test things, see if it works for the other terms. If it doesn't, modify it, figure out what you need to do to make it work for the other terms. And I know that sounds like terrible advice, but we have to start somewhere, and that's a good place to start. You start with a model, you test it, and then if your model doesn't work, you modify it, and just keep modifying it until you find something that does work. And that's the end. Ask if you have questions.